Hello everyone! So if you're watching this video clip, that means you're having hard time with IB Math or you're gonna take this course in the next year. So I am Choi, actually my full name is Jae-young Choi. I don't have English name, so nice to meet you. So this course is for IB Math higher level and standard level for both of them. So the thing is, this is going to be for both of you. That means some of part will not be necessary for standard level students. So you can skip this part. Okay, so I'm going to start with how it is made up of. So the thing is, IB Math task consists of 2 papers with only core section. So I'm not going to cover options, so only core. So during paper 1, calculator is not allowed. So you cannot use any kind of electronic devices. Also, in paper 2, you can use only calculator, no other electronic devices. And then both consist of short response questions and extended response questions. This is you only write down the answer, and this you have to show your work. And for IB Math higher level students, you should take paper 3 of option. So this is table, you cannot kind of see it, but I already explained almost everything. So for standard level students and for higher level students, you guys are given different time intervals to finish the paper. So paper 1 and 2 for standard level students, 1.5 hours, and then for higher level students, 2 hours for paper 1 and 2. And also because you guys have longer time, higher level students, you guys have more problems. And it only takes 80% of it is worth only 80% of the total score, total marks. And besides the papers, there is one thing called internal assessment. So it's required for all the students taking math, standard level and higher level. So all the students taking IB Math, standard level or higher level, should come up with an idea of mathematical investigation paper. You have to write a paper, and it is worth 20% of your final work. So it's a lot. Okay, so this is the book that I mostly looked. I studied. Also this one. So I give you 2 recommendations. The first one is this book, and the second one is this book. So when I'm going over the concepts, when I'm going over the concepts, and when I'm going over the examples, a lot of them, not all, some of them are from these texts because they give you good explanation on it. So I do not say that you guys have to buy it. If you have it, try these books too. And also there are only around 55 lectures for higher level, and about 45 lectures for standard level. That means I try to compress all the concepts in the short number, in a small number of lectures. That means I kind of spoke fast. So some might think, okay, this person speaks too fast. Then I recommend you to stop, to pause for a while and then finish your work and then start again. And then I use my own PowerPoint. So the PowerPoint will be uploaded in the form of PDF file. So download it, print it out, and do the work with me. And then also, like I said, I'm not gonna solve a lot of problems in this lecture. So I recommend you to solve a lot of problems from the textbook that I recommended, or try the past papers. So the styles are so different. And then there is a questions and answer Q&A question, Q&A bulletin board on the website. So just leave a question. So, write a post, write a comment. Only it's related to the concept that I explained, only related to the lecture, not any other questions. So how I'm gonna pay this lecture, how much is this lecture? No, I have no idea. So if you have questions, if you cannot understand the concept that I explained in the lecture, in the lecture video, then yes, leave a question on the Q&A board. That's all. So I hope you guys enjoyed the IB Math higher level and standard level with my lectures. Okay, bye-bye everyone. Hello everyone, welcome to IB Math course. So today we're going to go over function basics and linear function and equation. So these are very, very basic concepts, but you have to make sure about it. So first, function basics. So I'm going to go over what is function and how it's defined. So what is relation? Relation is a set of ordered pairs like this. So anything looking like this within parentheses, they're called ordered pairs. So for example, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Those are called a relation. So let's map it. So this is called a mapping, and this shows a relation between the first element and the second element. So 1 points to 1, and 1 points to 2, 1 points to 3, 2 points 1, 2 points 2, 2 points to 3. Okay, so now we know, okay, anything between two numbers can be defined as a relation. So what's the name of them? What's the name within this parenthesis? We also need to know about it. So the first element of the ordered pair is called x-coordinate. And the second element of the ordered pair is called y-coordinate. So when you write it down, we can write it down like this. The first one is x-coordinate, and the second one is y-coordinate. So for example, from the previous slide, we had 1, 2. So 1, it's x-coordinate, and 2, it's y-coordinate. So then, what do you call the set of x-coordinates? It's called domain. What about the set of y-coordinates? It's called a range. So this is the names of all the numbers in set of ordered pairs. So let's look at this problem. No, not the example. So there were 1 and 2 as x-coordinates, and there were 1, 2, 3 as y-coordinates. So 1 and 2, like I said, the first element is called x-coordinate, and the second element is called y-coordinate. And 1 and 2 combined together as a set, we call it domain. So the domain is the set 1 and 2. And we call 1 and 2 and 3 all together the range. So the range is the set 1 and 2 and 3. So the relation is anything. Anything could be like any relation. So between two sets, we call this a relation. Okay, so then what is function? This is really important. We have to define what the function is. So function is basically a relation, but there's one restriction, one limitation. Any of whose elements does not share x element. What does this mean? This is kind of not so clear. So in other words, x element has only one y element associated with it. So the example given in the previous slide was not a function because we had three ordered pairs associated with 1. So 1 points to 1 and 2 and 3 at the same time, but function cannot point to or more values, y coordinates. So the example from the previous slide is not a function. Okay, so how do you define the function more in detail? So first, a set of ordered pairs such as x and y. If you can represent any element in the relation or in the function as follows, then it could be a function. And x and y are in a special relationship. Like y is 2 times x plus 1. So 1 more than twice x. And this is really important. This is one of the most important things. No two ordered pairs can share same x coordinate. Like I said, no two x values can have two y values. And this is also really important. All x values must have a pair, which means we have domain of 1, 2, 3, 4, and we have range of 1, 2, 3, 4. But if 4 does not point any value in the range, this is not going to be a function. So for this to be a function, we have to exclude 4 from both domain and range. And then how do we denote it? How do you like write it down in mathematical terms? So basically we go with f of x or g of x. This is going to be the most common expressions that you're going to see in the math textbook or math exam. So f and g, actually this means the name of the function. If you have two different functions, f and g, that means they could be same or mostly they're different. And this means function y or function f is expressed in terms of x. And that also lets you know that x and y are in some special relationship. So just be careful. It can be denoted by f of x and g of x, and x means that y can be expressed in terms of x. So, okay, let's move on to the next slide. So we're given some special relationship between two values. So this is going to be domain, and this is going to be range. Okay, so one more important thing. So f of x, this is also mean the y value is going to be expressed in terms of x. So what do you know about it? So if we plug in some value into x, then we have some value y. So we call this x independent variable. And we call y to be dependent variable. This is pretty much clear because we can choose whatever we want to be the value of x. But y is always determined by the value of x and the relationship given to you. So here, y equals to x plus 1. Also, f of x equals to x plus 1. So if we plug in 3 into this equation, then we have to have 7 as a result. With negative 2, 2 times negative 2 plus 1, as a result, we have negative 3. Likewise, we have 11 as a result of plugging in 5 into the given function, given expression. So here, again, the domain is negative 2, 3, 5. As a set, altogether, range is negative 3, 7, and 11. So how do you tell if this is a function or not? So first, is there like older set or older pairs? Yes, there are 3, 7, negative 2, negative 3, 5, 11. Yes. And what about next one? Is it a relationship? Yes, 2x plus 1. So there's some special relationship between x and y. What about domain and range? Let's think about it. Okay, so no x values shared by like 2 or more y values. Also, all the values of x in the domain have a pair with the value in the range. So is this a function? Yes, it is the function. So let's find the domain and range. So this is really important. This is like the thing that students, you guys, look over. So as you guys think range and domain, those are not really important or necessary, but they are really important and they're really important, essential to math problems. So let's think about 1 over x. This also means y equals 1 over x. So if you plug in some value in text, then you get some value for y. But how do you find the domain and the range? First, actually, x can be any value. So we're going to say, okay, so x is all real number. So this means all real number. But there's one thing that you have to remember. So denominator, no, it cannot be 0. So except 0. Okay, let's check it with the graph. If you have a graphing calculator, just grab it and graph it, plot it. Then you're going to have some graph looking like this. Oh, okay. So there are all the points like this, points like this. One important thing is there's no value for x equals y. So this line is actually empty. So no value, like no x equals 0 point, points to any point here on this vertical line. What about range? Okay, so let's look at the graph again. So there are all the values from infinity to almost 0, 0 to negative infinity, but there's no point on x-axis. There's no intersection between the graph and the x-axis. That means, this is really important, range is also all real number, but y also cannot be 0. This is the really important, one of the most important things. So we are going to see a lot of problems, a lot of functions, but basically most of them have all real number as its domain and all real number as its range. So just be careful, the denominator cannot be 0, so we have to exclude it from the domain, because if we include x equals 0, that means this is not a function because there's no point, such as this. That means there's one missing x value in the domain, so we cannot call this a function. So range and domain, you have to keep in mind that you have to always consider domain and range and how to limit it and how to define it. Okay, so then how do you check the function graphically? Not with given function. If you're given only a graph and they're going to ask you how to find, how to check, how to determine the given graph is a function or not. There's one really good test called vertical line test. What does vertical line mean? It means this. So all you need to do is just draw some vertical line this at any point. So if you want to check if the function is, if the given expression, given the graph is a function or not, all you need to do is draw a vertical line at any point, and then you check if there are 2 or more intersections with one vertical line. So then how can we do it? Why does it work? So like I said, no x coordinates should share 2 y coordinates. X points to only one y value, which means if it has 2 or more y values, then the vertical line should have intersections, like 2 or more intersections with the given graph. So we only need to just draw the graph. Okay, let's check with some given graphs. So let's go with graph number B. So here, if we draw a vertical line, oh, there's no vertical line having 2 or more intersections with the given graph. So this is a function. Okay, let's do graph number D. So here, if we draw some vertical lines here, now we can check there are 2 points intersecting. 2 points and 2 points of intersection. So this means this is not a function, because this means that there are some points, some x values associated with 2 y values. Okay, what about H? So this whole means the value is not included here. So here, oh, it seems like this is a function, but if you draw some line on this point, because there's no hole on both, so that means this vertical line has 2 intersections with the given graph. Okay, so this is not a function. So you have 5 remaining, so you can do it at home by yourself and check whether graph A, C, E, F, G are function or not. Okay, so it's really easy. Again, all you need to do is just draw some vertical lines and check if each vertical line has 2 intersections or more. Okay, so what kind of functions are we going to learn? Like, what kind of functions are there? So these are the functions that you're going to learn in the future. So first, linear function. Second, quadratic function. Third, high order functions. These are determined by the maximum power of x. So here, it looks like this. Y equals ax plus b. Quadratic, the maximum powers, actually 2. So it looks like this. And high order, so it will look like this, but n is greater than or equal to 3. And exponential function, now we have x as a base, but now x becomes power, like this. And logarithmic function, we're going to learn detail about it. This is actually an inverse function of exponential function. So it looks like this. And trig functions, I'm pretty sure you learned about trigonometric properties before. So they're tangent x or sine x or cosine x, such as this kind of functions. These are kind of functions that you're going to learn in the future. And today, we're going to cover linear function. Okay, so linear function and equations. So what is linear function? Like I said, any function in this form, y equals ax plus b, is called a linear function. But there's one really important thing. It cannot be 0. Linear function, again, a cannot be 0, which means the coefficient of x is never be 0. It's never 0. Okay, so for example, y equals 3x plus 2. Is this a linear function? Yes, it is. Why? Because, yes, they're in the same form. But what about this y equals 2? This is not a linear function because a is 0. Yes, we categorize it differently. So we call it constant function. Constant means the number, right? So no matter what the value of x is, y is going to be always 2. So that's why it's called constant. It doesn't change. The value of y doesn't change. So that's why it's called constant function. So keep in mind, any function in the following form, y equals ax plus b, is called a linear function, and a cannot be 0. Okay, so let's move on to the next slide. Then what is a and b represent? So here we have a and b. What do they represent? What do they mean? So first, the coefficient a, this a represents gradient and slope. So in British English, we call it gradient. In American English, we call it slope. So for you guys, because you are in IB course, keep that in mind, gradient. Just gradient is A. What are constant B? It represents y-intercept. I'm pretty sure you learned it before, like in IGCSE or something, Algebra 2, Algebra 1, but I'm going to go over this very briefly. Okay, so gradient and slope. What is the definition of it? It's really simple. Change in y over change in x, which means if you change some value of x and if you change the value of y, there must be some ratio between them. So that's called gradient. In mathematical terms, we write it down like this. Delta y over delta x. This is called delta, and it means difference. So again, basically the gradient, the slope, means the ratio between change in y and change in x, and it's represented as, in this form, delta y over delta x. And again, delta means the difference between two values. Okay, or it could be also represented in this form, y2 minus y1 over x2 minus x1. If you're given x1 comma y1 and x2 comma y2. Be careful, like they have to be in the same order, 2 to 1, 2 to 1. Or it could be also be like this, y1 minus y2 over x1 minus x2. I'm pretty sure you know why, because if you isolate minus, then it will look like this. So, yes, you can just cancel minus sign, then you have the same expression. So this is the definition of the gradient. Okay, so let's move on to the next slide, which is really important. So you're given y equals 3x plus 2. And what do you know about it? What do you know about the function? So you know the gradient is 3. Okay, so that tells you, okay, if you increase x by 1, then that means delta x is 1. Then we know 3 equals, okay, so 3 equals delta y over delta x. So if delta x is 1, delta y is going to be 3. So it's going to be increased by 3. What about it's increased by 0.5? Yeah, delta x is going to be 0.5. So we know 3 equals delta y over 0.5. So we know that y is increased by 1.5. Likewise, you can do it with 7. Let's think about what if it's decreased. So if x is decreased by 1, that means delta x is going to be negative 1. Okay, then 3 is delta y over negative 1. So, oh, delta y is going to be negative 1, which means it's decreased by 3. So, if you increase x by some value, then y is going to be also increased, but at some ratio. But if you decrease x with some value, by some value, then y is going to be also decreased at some rate. So, like I said, the gradient means the ratio between the difference of y and the difference of x. So, let's think about the negative gradient. So far, we only thought about like positive gradient, but what about like with negative gradient? Y equals negative 5x plus 3. Okay. So that means delta y over delta x is negative 5. Okay, so let's increase x by 1 again. So delta x equals 1. Okay, so now we know delta y is negative 1. Okay, so we have positive sign here, but we have negative sign here. So y is decreased by 5. So now if we increase x by some value, now we know the value of y is going to be decreased by some value. But again, at some ratio, what if we decrease the x by 1? Then delta x is negative 1, correct? Then, because we know delta y over delta x is negative 5, delta y is going to be 5. Okay, this tells you, okay, if we decrease x by 1, then y is going to be increased by 5. Oh, this is really important and interesting. Why? Because if you increase x, then the y is going to be decreased. And if you increase x, decrease x, then y is going to be increased. So they the difference, the delta x and delta y, they have opposite sign. Okay, so be careful. So if the sign of the gradient is positive, then y is increased if x is increased, and y is decreased if x is decreased. That means delta y and delta x have the same sign. But if the sign of the gradient is negative, okay, so delta y and delta x have opposite sign, which means x increased, y decreased. X decreased, y increased. So this is all you can know about gradient. Let's move on to the next slide then. Intercept. What is intercept? So for here, intercept means if the value of y is 0 and we have some value for x, then that point, that older pair is called x-intercept. Vice versa. If the value of x is 0, then we call the point y-intercept. So let's do problem number 1. You can do number 2 at home. So we want to find y-intercept. So it's easy. X is 0, right? So y equals 3 times 0 plus 2, so which is 2. So 0, 2, this point is going to be y-intercept. What about x-intercept? We know y coordinate must be 0. So 0 equals 3x plus 2. Therefore, 3x equals negative 2. X is negative 2 over 3. So negative 2 over 3 comma 0. This is going to be the x coordinate of the problem number 1. The function y equals 3x plus 2. So easy. X-intercept, y-coordinate is 0. Y-intercept, x-coordinate is 0. All you need to do is plug 0 into x or y and have the value of x or y again. Okay. So linear equation is really simple. Instead of y, we have 0 on the right-hand side. So here, why do we want to do it? We want to just have to find the value of x satisfying the given equation. So here, x is negative 2 over 3. Right. So this is the solution for this linear equation. And 5x equals 3, where x is 3 over 5. This is the solution of the linear equation. So simple, right? So instead of like y, we have 0 on the right-hand side. So we plug in 0 into y. So like I said, I plugged in 0 into y. What is the relationship? So the solution of linear equation, it means x-intercept. So you can also graphically solve this problem. What? If you're given a graph of linear function, then the solution where y is 0 is going to be the x-intercept of the given graph is going to be the solution of the linear equation. Okay, so then how do you graph it? So this is really easy. Linear function, you know the graph is just a line. So all you need to do is have 2 points. Find 2 points. For example, I found it. 0, 2, it was y-intercept, and negative 2 over 3, it was x-intercept. So make a line. So this is the graph of linear function. And like I said, this is going to be the linear equation solution where 3x plus equals 2 equals 0. This is going to be the solution of the linear equation. Okay, so next one, y equals negative 5x plus 3. So, like I did, we have 0, 3 and 3 over 5. Oh, 3 over 5, 0. So the line looks like this. So, okay, this is really important. So these are the line. This is the line of that equation, and this is the solution of negative 5x plus 3 equals 0. So one last thing I want to tell you about is, when I had 3x plus 2, the graph was going up to the right. But with negative gradient, the graph goes down to the right. So this is what you have to write down. So the linear equation looks like this. If it's negative, the linear equation looks like this. So again, if the gradient is positive, its graph is going up to the right. If it's negative, the graph is going down to the right. Okay, so this is what we learned today. So function basics, linear equations, and linear functions. This is really easy. You might think these are not really important, but these are the base of your mathematical concepts and abilities. So this is just for today, and we're going to learn something more fun next time. Bye.